Welcome to my talk this afternoon about dinosaurs of the 21st century, masters of the sky. When you talk about dinosaurs, we have to understand that most of them lived a very long time ago. The first dinosaurs, they evolved in the Triassic period about 230 million years ago. And the Triassic, the Jurassic, and the Cretaceous period, they are sometimes called the age of the dinosaurs. And they range from about 250, the start of the Triassic, to the end of the Cretaceous period, about 65 million years ago. If we go back a bit further in time to the Permian period, we'll notice that there were no dinosaurs around, but the dominant land-living animals were called the synapsids. Now, a synapsid is a group that also include mammals. But some of these early synapsids, they're called the therapsids. And this is one of the more famous one, Dimetrodon, found in rocks in North America. You can see it had this huge sail on the back. We think they used them to regulate their body heat, maybe facing the sun in the morning to heat up more quickly. But as we go into the Triassic period, we notice that the therapsids, they become smaller in size because they are now facing competition from a new group of vertebrate animals, the dinosaurs. And eventually, most of these synapsids, they become really, really small, about that size in the Triassic period, about 230 million years ago, and they evolve into the first mammals. So this is one of our ancestors, whereas dinosaurs are not. Now, the first dinosaurs that we have any evidence of are about 230 million years old. This is Herrerasaurus, one of the best known of these really early dinosaurs from the Triassic period. It's been found in rocks in Argentina. And you can see it's a meat-eating dinosaur, sharp teeth, strong jaws, and it was a two-legged creature. Now, when we discuss dinosaurs, we have to remember that there are two major groups of dinosaurs, and the way we classify them is that by looking at the hip structure. These are the hip bones of one of the groups of dinosaurs, and these are the ones of the other type. Now, you can see that there is a hole in the middle here where these three bones join. Now, that is a character that is unique to dinosaurs. This group is referred to as the Saurisian dinosaurs. They include the meat-eating dinosaurs like Tyrannosaurus rex. It also includes the giant Brontosaurus type, the big sauropod dinosaurs, which were plant-eating dinosaurs. Whereas the Ornithopodians, they include various plant-eating dinosaurs like Stegosaurus here, for example. If we start looking a bit more into detail at the Saurisian dinosaurs, as we get into the Jurassic period, there is a general increase in size if we look at the top predator, the Dinosaurian top predator. And this is a well-known dinosaur from the Upper Jurassic, about 150 million years old, from North America, called Allosaurus. It was really a large predator, could grow to possibly as much as 12 meters in length, and was certainly the apex predator on land in North America at that time. You can see it had a really, really big claws, big strong arms, and a large head. It would have been an absolutely formidable predator. As we go into the Cretaceous period, which is the last of the three eras that make up the Mesozoic, the age of the dinosaurs, some of these allosaurids that are related to Allosaurus, they attain gigantic size. And this is the biggest of these allosauroids. It's Giganotosaurus. It's been found in rocks in Argentina, about 100 million years old. And it was an absolute monster. It could grow to as much as maybe 14 meters in length. And this is the skull of Giganotosaurus, and as you can see here, go back one step. The skull could reach almost 2 meters in length. Now that's a big head. You can see that also it has quite a few openings in the skull, and that is partly to make it lighter, but also to provide space for the jaw muscles, closing the jaw. So it had a powerful bite. The teeth are quite narrow, shaped a bit like a knife, so it could cut through the flesh of its prey. This is just to give you an idea about how big Giganotosaurus was compared to a human. It would easily be able to swallow a human whole. Along with these giant Allosauroid, we call them Theropod, the meat-eating dinosaurs. I'm going to use that term, Theropod. They were predominantly successful in the southern continents, or the southern hemisphere. In the northern hemisphere, there was a group of rather small theropod dinosaurs, meat-eating dinosaurs, called the Silverssonians. We have evidence of them in, for example, in North America, well-preserved specimens, and they were about maybe 2 meters in length. But as you go into the Cretaceous period, one branch of that group started increasing in size and eventually produced the gigantic Tyrannosaurs. And this is Tyrannosaurus itself, the biggest of these Silverssonians. So although T-Rex looks much like Giganotosaurus at a first glance, they're actually not that closely related. And T-Rex had an absolutely massive skull. It had by far the strongest bite of any meat-eating dinosaurs. And unlike Giganotosaurus, it had the ability to actually crush bone. It had a bone-crushing dentition. The teeth are not particularly narrow. They're quite thick, shaped a bit like a banana. So it had a absolutely massive bite. Very, very large head. We can see that their arms are tiny, and they only have 2 fingers. The arms, they're so small, so we are not quite sure what they actually use these arms for. They weren't even long enough to scratch themselves under the chin. So we're not sure. There is a, if you follow this group, the evolution of this group, there is a general reduction of the size of the arms, but an increase in the size of the head. So they clearly wouldn't have used them during their hunting, for example. Now, this particular T-Rex is one of the best known. It's the largest, most complete T-Rex skeleton ever found. And people who work on these Tyrannosaurs, they've noticed there are 2 different morphs of T-Rex. One is a bit larger and has robust bones. The other one is slightly smaller, still gigantic, but slightly smaller, a little bit more gracile. And some suspect that the larger morph represents the females. For example, in birds of prey, the female is quite a bit bigger than the male, whereas in crocodiles, for example, the male is much bigger than the females. And they suspect that this larger form represents the females. Therefore, they call this one Sue. And she is named after the lady who first found her bones. There's an interesting story pertaining to this particular specimen. It was dug up by a company who specializes in collecting these dinosaur remains. But eventually it got confiscated by the FBI and people were put in jail and all sorts of drama. Eventually the Chicago Film Museum ended up purchasing it for about $8 million. It takes a lot of time excavating these dinosaurs, so they're not cheap if you want to buy one. Another interesting development in the theropod dinosaurs, if you go from the Jurassic into the Cretaceous, especially in the Tyrannosaurus, is the development of a stereoscopic vision. Now that's a huge advantage if you are a hunter, because it enables you to judge the distance. It's also good, you don't necessarily have to be hunted, but if you're a climbing animal, that's also very necessary, so you can judge the distance from one branch to another. Whereas if you are a herbivore like a wildebeest in Africa, it's better to have the eyes on the side, because you can scan the perimeter for predators. So there's been a bit of a dispute whether T-Rex was an active predator. Almost all paleontologists working on these theropod dinosaurs regard it as a predator, but there's one in particular who claimed that T-Rex probably was a scavenger. because some parts of the brain that are related to the smell are well developed in T-Rex. It's a bit difficult to argue why T-Rex needed to develop a stereoscopic vision. It was just a scavenger. Because that's not, T-Rex was by far the biggest of the theropods of its time, so it would be able to chase off any other predators from a kill. Now, when we look on these theropods, it's interesting to see the huge variety in shapes and the way the skeleton is made up. This is the most interesting theropod dinosaur found in the 1950s in Mongolia. Herrerasoros, I can hardly pronounce that word. These claws are up to 1 meter in length. They're about that big. They're by far the biggest claws of any animal. And when they first discovered this animal, they only found the arms and the shoulder blades, so they tried to figure out now what the rest of the dinosaur looked like. Maybe it looked like a gigantic Tyrannosaurus rex, for example. But when they found other related dinosaurs that belong to the same group as these ones, again with a big claw, a huge hand, it turns out that it represented the most bizarre-looking dinosaur you could possibly imagine. And that just shows you how much there is to learn about these dinosaurs. Who could possibly had predicted that the owner of these arms would look something as silly, dare I say, as this one? This is a theropod that had abandoned the meat-eating habit and turned into a herbivore. So it had a small head, and it ate plants, had a big, huge gut, and then these big, whopping claws. Quite amazing. Another very interesting group of theropod dinosaurs, they show what we call convergence with the crocodiles. They are the Spinosaurids. I'm not sure if any of you saw one of the Jurassic Park movies. There was one Spinosaurus itself that was featured in that movie. I think it jumped and killed a T-Rex. Possibly somewhat unlikely. Anyway, these Spinosaurus, they're a fish eater. We can tell if you look at the jaws here, they are narrow, just like in a freshwater crocodile. Now, freshwater crocodiles, they have specialized on eating fish. And the advantage of having narrow jaws, if you are a crocodile and you feed almost exclusively on fish, is of course that you can close your jaws much quicker. If they are broad, like in a saltwater crocodile, you have to fight the resistance of the water as you close your jaws. But it's a trade-off, because the freshwater crocodile is not that terribly well adapted to grabbing hold of a pig, for example. Then it's better to have a thick and heavy jaws. So these Spinosaurus were clearly fish eater. Some of the Spinosaurids, like Baryonyx, was found with fish scales preserved in its abdominal cavity. And this is Spinosaurus itself. Spinosaurus had a huge sail-like structure on its back, and maybe they used that for display, or maybe that they used it to heat up quicker in the morning by facing the sun. We don't know, but they are most bizarre-looking theropod dinosaurs. They had big, quite long arms, big claws. Would have been useful if you tried to catch a fish, a bit like a grizzly bear, you can imagine. And Spinosaurus was actually the largest of all theropods. Some remains indicating that they could grow maybe to 16, 17 meters. So they were absolutely enormous. Now, the other big group within the Saurischian dinosaurs are the sauropods. And this one, Apatosaurus, was also formerly known as Brontosaurus. The way it works when we name things is that the oldest name that's been properly published in a scientific journal has priority. And here it turns out that Apatosaurus was the earliest name applied to this creature, but then it got forgotten and someone named it Brontosaurus. So that's why we these days call it Apatosaurus rather than Brontosaurus. Now, the interesting thing about the sauropods, apart from being the biggest by far, the biggest land-living animals of any type, is that if you look at the vertebrae here, you can see that they are very, very light. They are what we call pneumatized. There would be air sacs penetrating into the bone making it much, much lighter. That's an interesting character because that's seen also in birds. The other big group, apart from Saurischian, are the Ornithischians. And I'm just going to show you some example of Ornithischian dinosaurs. This belongs to a group called the Marginocephalians, and these are the Ceratopsians, some of my favorite dinosaurs with this huge structure behind the neck. Many of them had spines. We have Triceratops, for example, big horns, and it's easy to imagine that this was used as a defense against the Tyrannosaurids, because these were coeval with the Tyrannosaurids in North America, but also in Asia. The Ceratopsians, they evolved in Asia and then later migrated to North America. And it was for a long time believed that that migration took place across the Bering Strait, when there was a land bridge that were present at times during the age of the dinosaurs. But just a few years ago, I was part of a team that described the first Ceratopsians from Europe. And since that publication, there's been several examples of Ceratopsians described from Europe. So it's possible that they maybe managed to get to North America via Europe as well, Northern Europe. Here's another group of Marginocephalians, the Pachycephalosaurus. Most bizarre looking dinosaur. Now this bony dome could be up to 10 centimeters thick, the actual bone itself. It looks like something from a science fiction movie, doesn't it? And obviously paleontologists, they have speculated what they used this for. Maybe they were headbutting each other, maybe the male used it to headbutt each other. But it's hard to tell. But interestingly, most of them are quite small. They weren't very big dinosaurs, so it's possibly they could use it as a defense as well. The other group, the shield bearers, the Thyreophorans. Again, these were slow-moving animals. They wouldn't be able to outrun a big theropod, for example. So they instead had a more passive defense in the shape of bony scutes in the skin. Many of them had sharp cusps and had big spikes. Some of them had an active weapon at the end of the tail, a huge bony club. And by swinging that back and forth, they would be able to cripple a T-Rex that would come too close. So that would be quite formidable animals to subdue. We have the Stegosaurs, another group, and there's little doubt what they used the spikes at the end of the tail. They obviously were used for defense. Now these plates on the back, on the other hand, are a little bit more difficult to explain. It seems that they had a rich network of blood vessels, so maybe they used them to heat up in the morning. That's possible by facing the sun. We are not quite sure what they used them for. The other big group of Ornithischians represents the Ornithopods, the Herrerasaurs. Again, they were featured in the Jurassic Park movie. We have a ornithopod found in Australia, a large one, Mataborasaurus. If you've ever been to the Dinosaur Gallery in Perth, you'll see that we have a cast of one of these ornithopods, Mataborasaurus, about 7.5 meters in length. Thomas Huxley, a British biologist, and most of the time a strong support of Charles Darwin, who presented his theory of evolution, that life on Earth has progressed through evolution to create more advanced forms. Now he presented an idea in 1880 that birds evolved from dinosaurs. And that was met with significant skepticism. Now, Huxley, he looked at the oldest known bird that has ever been found in rocks of 150 million years old in Germany, Archaeopteryx. Now, Archaeopteryx displays features that some are very bird-like, like they had wings, feathers like a bird, whereas it has a long tail like a dinosaur, and it also had teeth like a dinosaur. But most features indicates that it was a bird, and it's generally classified as a bird. And this is a reconstruction of Archaeopteryx. 150 million years old creature. But Huxley, he pointed out that some of the small theropods of the same age in the same general area in northwest Europe looked very much like Archaeopteryx if you just removed the feathers. And this is Compsognathus, one of these small theropods. And that was the basis for his idea that birds actually had evolved from dinosaurs. And this is a reconstruction of the skeleton of this small Compsognathus dinosaur. However, as we go into the early 1900s, 1920 to 1969, I call it the dark ages in dinosaur research. Paleontologists, they had abandoned the idea that there was a close link between birds and dinosaurs, and they started regarding them again as cold-blooded, slow, dumb creatures. And this is classic illustrations showing a T-Rex walking up towards a group of Ceratops, and it's walking upright, standing almost like a kangaroo when they're resting, with the tail dragging behind its leg. And we found lots of trackways from sauropods and from theropods, and none of them show any tail dragging, for example. But in 1969, there was an amazing discovery published in North America. John Ostrom describes the terrible claw Deinonychus. Now, this was a most fearsome-looking dinosaur. It could grow to about 3.5 meters. But on the second toe, it had a huge enlarged claw, a raptorial claw. And they probably held that off the ground when they were walking. Steven Spielberg picked up on this in his Jurassic Park movies. And he used one of these raptor, Velociraptor, which is actually a smaller raptor, smaller than Deinonychus. But he used the name, he probably liked the name, Velociraptor. But the size of the raptor's features in those movies is more representative of corresponds better to Deinonychus. And this is the skeleton of Deinonychus. Other interesting feature, they had ossified tendons, like bony rods, so they could hold their tail well off the ground, rather stiff as a counterbalance to the anterior portion of the body. The arms were big. The hands are almost bigger than the feet, and that's another characteristic of these raptor dinosaurs. They also had a well-developed sternum, much like birds, and some had a sternal keel. And in birds, that keel is the attachment site for their pectoral muscles, their big flight muscles in the flying birds. Now, in the Jurassic Park movies, the raptor dinosaurs, they were portrayed as really vicious, aggressive, intelligent creatures. Now, this is one of the most amazing fossils, dinosaur fossils, that's ever been found. It was found in rocks about 80 million years old in Mongolia. It shows Velociraptor itself holding on to the head of a Ceratopsian dinosaur. And they probably died as a result of a collapsing, maybe wet sand dune that collapsed on top of them. And you can see here that it looks like the Ceratopsian is actually holding on to one of its arms in its jaws. Now the Protoceratops, the Ceratopsian in question, would have been a rather slow animal, so there's no way it would be able to outrun these the raptors. So it shows that the raptors had no difficulties or wouldn't hesitate attacking a plant-eating dinosaur that was much bigger than itself. Now, the idea that Ostrom, again, he revitalized the idea between a close link between small theropod dinosaurs and birds, in particular the raptor dinosaurs and birds. And that idea grew in popularity among paleontologists working on dinosaurs. And even more so when we started finding a whole range of small raptor dinosaurs in 120 million year old lake deposits in China. Now, this is one of the most common raptor dinosaurs found in these Chinese lake deposits, Microraptor. This is the skeleton. And not only do we find the skeleton of dinosaurs in these lake deposits, we also find a lot more. Now, again, this is Microraptor. That's the head. This is the arm, the leg, the tail, and these are flight feathers. It turns out that almost all the raptors we are finding in these Chinese lake deposits, certainly those that are really well preserved, they were covered in feathers. They had flight feathers as well. You can see it has flight feathers on its leg. It even has feathers at the end of the tail. Most likely it climbed trees and then it could glide maybe from one tree to another, but it appears it also was probably able of some sustained flight. And that was used like some of the arguments in the 1920s, 1930s and a bit later, why birds couldn't have been derived from dinosaurs, because dinosaurs, they don't have feathers. Well, now we know what they do. They were covered in feathers. Not only are we finding feathers in raptor dinosaurs, but also in some of the more what we call basal theropod dinosaurs that are more distantly related to the raptor dinosaurs. But again, some paleontologists working on birds and some ornithologists, they said, oh, well, yeah, we agree. Some of the raptor dinosaurs, they had feathers, but there are certain skeletal structures in birds that are not present in dinosaurs. One is the wishbone. The collarbones are fused in the birds, form the wishbones. So they said, well, look, we don't have any wishbones in any dinosaurs. It didn't take long for us to start finding wishbones in dinosaurs. Dinosaurs, they have wishbones. So there goes that objection. But then they pointed out again that, well, birds, they have a most unique set of lungs. The way a bird breathes is not like us. We inhale the air in the lungs and then we expel it like a bellow, in, out, in, out. The way it works in a bird is quite different. They have an extremely efficient way of getting rid of CO2 and extracting oxygen. Now, apart from the lungs, and the lungs in a bird are not squishy like ours, they're quite stiff. And our lungs have little tiny alveoli, dead-end alveoli. You don't have that in birds at all. And in addition to the lungs, they have several pairs of air sacs. And one of them is unpaired, the clavicular air sac. But they have anterior thoracic air sacs, posterior thoracic air sacs, and abdominal air sacs. And I'll show you how it all works. The way it works when a bird breathes, it inhales air here, but instead of going into the lungs, it goes into the posterior air sacs. So the posterior air sacs expand. They are sucking in air here, but then you have an anterior set of air sacs that also expands at the same time when the bird inhales. So air is going in here, but on the other hand, and then you have a valve-like structure here, or at least it works like a valve, because when you dissect the bird, you don't really find a typical valve. So when this anterior air sacs, when that expands, it sucks the air out of the lungs. And then when the bird exhales, there is a valve-like mechanism here that prevents this air that's now in the posterior air sac from going out the other way. So when they contract the anterior air sac and the posterior air sac, that air is now going out here, whereas this air is now going into the lung. So that means that the whole system works like a one-way. Air comes in here, and then it goes out there. So there's never any real mixing of air that is enriched now in CO2, carbon dioxide, with oxygen-rich air. For our lungs to work as efficiently, we would sort of have to be able to exhale all the air, and we can't. We can't really collapse our lungs. So it's a superior way of extracting oxygen. And the interesting thing also about this system is that these air sacs, they have little projections that actually grow into some of the bones, into the vertebrae, for example, make them lighter. The clavicular air sac have projection that grows into the wishbone. And the ornithologists, they pointed out, well, if dinosaurs were birds, shouldn't they have the same advanced breathing system? Shouldn't we see evidence in the skeleton indicating these what we call pneumaticization, so these holes where part of the air sac had grown into the bone? Well, a couple of years ago, paleontologist Paul Sereno and colleagues described the first case of a pneumatized wishbone in a theropod dinosaur. So there we go again. What we thought was absolutely unique character to birds is now present in at least one theropod. It's probably present in other theropods as well, but in order to find this structure preserved, the bone has to be exceptionally well preserved. In most cases, when we find dinosaur bones, they have lots of minerals encrusting the bones, and we might not see all the small foramina. So it partly was a result of exceptional state of preservation. So here we have what we thought were absolutely unique characters, birds present in dinosaurs as well. This is, by the way, the wishbone of one of the goose species, the magpie goose. And this particular theropod, Herrerasoros, had lots of well pneumatized vertebrae. You can see here the space here where the extensions probably from the cervical layers, actually not really that involved in the actual respiration. And dinosaurs, Saurischian dinosaurs, they tend to have them all along the vertebral column. But the more importantly is the presence of these holes, these foramina in bones, where they really could only be supplied with this extension of the air sacs from air sacs that are directly involved in the respiration. So it appears that dinosaurs, they were not these slow, cold-blooded creatures that they were portrayed in the mid-1900s, around 1950 thereabouts. Instead, they were highly efficient. The mere fact that many of them were covered in feathers, not only raptors, but other theropods as well, that's a good sign of the creature being warm-blooded, because that provides an insulation if you're rather small. Whereas if you're very big, you don't need really any feathers or much hair for that matter. I mean, look at elephants, for example. Now, as a result, we now have changed the view of how we view birds from a classification point of view. There are so many characters that link birds to raptor dinosaurs. So it becomes almost ridiculous trying to argue that birds are not closely related to dinosaurs. In fact, they are so closely related to dinosaurs, so we now classify them as dinosaurs. So this is just to give you a general idea about how we classify them. Here we have the main division into the Ornithopod, the plant-eating dinosaurs, and the Saurischians, the meat-eating dinosaurs, which also include the plant-eating sauropods. And you can see here up at the top we have the penguin, a bird, grouped together with the raptor dinosaurs. So it appears that the birds are deeply nested within the dinosaur tree. So that also means that the dinosaurs actually didn't go extinct at the end of the Cretaceous 65 million years ago. They survived. We have 10,000 species of dinosaurs living. Isn't that encouraging? When we talk about dinosaurs, we have to remember that you often find different dinosaurs in the northern hemisphere compared to the southern hemisphere. The configuration of continents was different back 150 million years ago, for example, than it is today. In the southern hemisphere, all the continents were joined together into a supercontinent called Gondwana. So we find similar dinosaurs in South America and Australia. They could migrate from one continent to another. Maybe that was a dinosaur. In Australia, we don't have too many places where you can find dinosaurs. We have two main sites. One is in Victoria, some coastal cliffs, where they are excavating lots of dinosaurs, but mostly it's isolated bones. They haven't found any complete skeletons of dinosaurs there, but lots of smaller ones, particularly smaller ornithopod dinosaurs in particular. The other area is in Queensland. There are a couple of sites up there. We have Minmis. Minmis, the most complete dinosaur ever found in Australia. It was belonged to this group, the Thyreophorans, the shield bearers. Another one, Matabarosaurus, and as I mentioned, we have a cast of a Matabarosaurus skeleton on the display in the Diamonds to Dinosaur Gallery. I'm sure you all have visited. But the main site finding dinosaurs in Australia is a town in central Queensland called Winton. And they are excavating dinosaurs in Winton as we speak. Just a couple of years ago, they described Venator. That's the most complete meat-eating dinosaur ever found in Australia. Had big claws on the hand, and would have been maybe about 5 meters in length. And apart from Venator, they also described 2 species of large sauropod dinosaurs belonging to a group called the Titanosaurs. Dimetrodon is one of them, was a very robust, stocky sauropod, maybe 17, 18 meters in length, and would have been quite heavy, possibly weighing as much as 15 or maybe 20 tons. The other one, Winton, a titan, obviously named after Winton, is small. It's not much. It's about the same length, but a little bit more gracile. Maybe not quite as heavy, but still gigantic. Now they're finding so many dinosaurs in Winton, so they built a dinosaur museum there. So if you ever go to Winton, check out their museum. I think it's called Age of the Dinosaurs. Yeah. Now, what about Western Australia? Well, this is actually a photograph of me out at the site near Mora looking for dinosaurs, and I almost look a little bit depressed there as if I haven't found anything. Now, over the last 100 years, we've been looking for dinosaur bones in Western Australia. We found 5 fragmentary bones. That's it. 5 bones. I didn't find any bones on that day, or the next day for that matter, but I certainly kept trying. Now, when you look for dinosaur bones, you don't want to look in marine sediments that were laid down in the ocean because you wouldn't find any dinosaurs there. You want to look, the best type of sediment is what we call a floodplain sediments. Sediments that were laid down on floodplain, typically during a flooding episode. Maybe dinosaurs drowned trying to cross a river, and their carcasses were swept away and ended up maybe on a point bar in the river, and they were covered by sediments. So you want to look at a floodplain sediment, obviously from the age of the dinosaur. This is the right type of sediment, of the right age, but we didn't find any. And here I am again, looking into the hillside. This particular outcrop here, there's an alternation between sand and fine mud, and that is probably what's referred to as a crevasse splay deposit. During a flood episode, when you have the strongest flow, you get a lot of sand spread over the river banks and then followed by mud. So you tend to get sand and then mud, and that might represent a single flooding episode. Didn't find any here. The main reason why we don't find a dinosaur in Australia, apart from the possible fact that I might be totally incompetent when it comes to finding dinosaurs here, that's possible, is that 140 million years ago, Australia started separating from India, or the part of India that's now under the Himalayas. So it's just drifting apart. And when two continents starts to, when a continent split up into 2 continents, the first thing you get is a rift valley. There's a place in East Africa called the Rift Valley, East African Rift Valley. And if you go to Perth, you can actually see the remnants of that Rift Valley. That's the Darling Fault. That's part of that Rift Valley, when Western Australia drifted apart from India 140 million years ago. But what happens now when 2 continental plates just drift apart is that you don't get much what we call uplift. Whereas in the other scenario, where 2 continental plates collide, one of them will be forced underneath the other, and you get the formation of a mountain range. The Andes is a good example, where you have a oceanic plate is forced underneath a continental plate, and you get mountain formation. So that means the whole rock is rises up, and you get increased erosion and a constant supply of fresh rock. But if a part of a continent sits near the sea level for tens of millions of years or hundreds of millions of years, it will be very deeply weathered. That's a problem. I'm sure there were dinosaur bones here originally, but they are most likely have been leached out by the rainwater, for example. Rainwater is a bit acidic. Rain picks up CO2 and forms carbonic acid, and it will leach out bones over time. It's a very scenic place, though, so it's a real shame I didn't find any fossils. On the other hand, in April, I went on a little trip to Alberta in Canada. Now, this is a fantastic place. It's maybe 50 kilometers north of a town called Drumheller. And this area is called the Dinosaur Provincial Park. I'm sure you can figure out why it's called Dinosaur Provincial Park. It's just full of dinosaur bones. And these are the right type of sediments, about 75 million years old, floodplain sediments. You had, imagine, meandering rivers working their way towards the ocean. And during flooding episodes, that's when you get sediments spread over the floodplain. And maybe dinosaurs drowned, and you can later find their bones sticking out of the rock. Now, I couldn't help myself, but I went down into these gullies and started looking for bones. And guess how long it took for me to find a bone? In Western Australia, it takes on average 20 years. Anyone? No, it took me 20 minutes. It took me 20 minutes. There it is. It's probably part of a leg bone. Yeah, 20 minutes to find a bone. And I was looking in an area where there's been a lot of tourists. So it's been picked out pretty well. In some areas of the parks, there's so many dinosaur bones, you have to be careful where you put the foot down, or you'll step on a dinosaur bone. I've been to some of these similar outcrops in Montana, in the US, and in some places you can just sit down and start picking up teeth of raptor dinosaurs. In some places, one of the best places to look for small dinosaur bones and small dinosaur teeth is there's particular species of ant that whenever they build their little ant nest, if there's little fossils, they will actually pick up the fossils. So the ant hill might be made up of 1/4 of vertebrate fossils from the age of the dinosaurs. So if you're real mean and sieve the ant hill, the ants get a bit upset, you might find a lot of vertebrate fossils. Now, although we don't have many dinosaur bones from Western Australia, we have some really good dinosaur footprint sites. Well, one site up in the Dampier Peninsula, all the way from a bit south of Broome, and for a stretch of almost 100 kilometers. And particularly footprints of sauropod dinosaurs are very common. And this image here, you can see a trackway of a sauropod dinosaur walking along. And sauropods, obviously, they were being very large animals. They were very heavy. You can see here where it puts its foot down. It's so heavy, so the layers underneath here have actually buckled. You can see the deformation going down maybe 1/2 a meter due to the sheer weight of these sauropods. Some sauropods may have weighed as much as 50 metric tons, like 5 or 6, 7 African bull elephants. Now, that was the last image I had, and I thought this was rather suitable. Kentucky Fried Dinosaur. So the main message is basically that although it is a tragedy that all the large dinosaurs died out 65 million years ago, we should embrace the fact that we have about 10,000 species of living dinosaurs, and that paleontologists working on dinosaurs these days, they with almost no exception classified birds without a doubt as dinosaurs. Because all the characters that have been used to differentiate birds from dinosaurs, we are now finding these characters in dinosaurs as well. And when you look at many birds, there were quite a few ancient bird groups in the Cretaceous. Those birds have now gone extinct, that again show many intermediate stages between a typical dinosaur and a bird dinosaur. For example, they might have a longer tail, or maybe they had a short tail of modern birds, but they had instead teeth, proper teeth, for example. I've collected bird teeth myself in rocks 80 million years old in Wyoming from an anthill. Yeah, I'm sure they forgive me, the ants. So basically that was the last image I have, and I'm glad you all came to listen to this, and hopefully you've learned a bit about dinosaurs and birds. Thank you.